17.5 is the Grignard reaction, or shall we say reactions. You learned about how to make the Grignard reagents before. They are reagents that involve a carbon-magnesium bond, so that makes these organometallic species, organic and metallic. Magnesium is a metal. Probably the most common place you've run into it is that it's used in the skin of airplanes because it's very light and yet sturdy, and much less reactive than the alkaline earth metals like lithium. Lithium is lighter, but of course lithium is also much more reactive. For the Grignard reagents, R here has a very broad range of structures that are available. It can be primary, secondary, tertiary. It can be aerial and vinyl. Okay, that is sp2. sp2, sp3. It can also be sp. with different groups here on the alkyne. So there's almost no Grignard reagent for which this will not work. These then react with different kinds of carbonyls. We're going to look again at a carbonyl. And I'm going to use X in this case not to equal a halogen. Well, let me change my mind. I'm going to call this one Y, because I've already used X. And X in the case of a Grignard is a halogen, typically chlorine or bromine. Can be iodide also. Now, what can Y equal? Well, Y can equal a hydrogen, in which case we're adding to an aldehyde. It can equal another R group, in which case we are adding to a ketone, or it can equal OR prime, in which case we are adding to an ester, and these give very different products. So if we add to an aldehyde, depending upon the structure of the aldehyde, we get, of course, in all of these cases, an alcohol. So these are different kinds of alcohol syntheses. If it's an aldehyde, if it's a special aldehyde, the carbonyl has two hydrogens attached to it. Do you recall what that one is? Maybe if you've been in a biology class where you had to do a dissection, you recall the smell of formalin. That smell is formaldehyde, which is in formalin. Formalin is a mixture of water and formaldehyde. And this gives us primary alcohols when it adds. If it's a normal aldehyde, we get secondary alcohols. If it's a ketone, we produce tertiary alcohols. And if it's an ester, again, we produce tertiary alcohols. So this is the general reaction for Grignard reagents. Now, let's look at some specifics. Specific reaction. Well, let's take, for simplicity's sake, our phenyl Grignard. Okay, magnesium chloride here is a part of the Grignard reagent. Now, if we react this with formaldehyde, we make a carbon-carbon bond. and we've made a primary alcohol. And you can see here the formaldehyde. And so only with formaldehyde can we produce a primary alcohol. If we react it with acetaldehyde, so the little squotes there mean bring down what's above. We get a secondary alcohol. And if we react it with a ketone, we'll take something simple here for illustrative purposes today, again with the same Grignard. We get a tertiary alcohol. So with formaldehyde, we can produce a primary alcohol. With any other aldehyde, we produce a secondary alcohol, and with ketones, we produce tertiary alcohols. Now, recognizing the kind of product you make is important in analyzing synthetic problems. Because if you need to make a tertiary alcohol, you wouldn't be investigating things using formaldehyde. So by recognizing the functional group that you need to make, you know what you need to start with. Okay, so those are the aldehydes. Now let's look at a couple more specific examples. What if we have an ester? Go back to our methyl benzoate. And if we react that with, let me change markers. This one seems to be getting tired. So if we react our phenyl Grignard with methyl benzoate, we actually need 2 of these for the reaction to go to completion. I'm going to change to another color here. Hopefully this will show up. See that one good? Yeah. And these 2 phenyl groups are from the Grignard reagent. So I switched colors on you there, but make sure you follow those through. The gray ones came from the Grignard, the orange atoms came from the ester. And the reason for this is, like we saw before, the first Grignard adds and it makes a ketone, and we already know that ketones will react again. In fact, they react faster than esters, and you get the tertiary alcohol. In this case, this is actually a special alcohol. It's called trityl alcohol, triphenyl methyl alcohol. Of course, it will very readily generate the carbocation at this position because of conjugation with the phenyl groups. So it's a very useful reaction, but you need to understand the scope and limitations because it first produces the ketone, which then reacts faster. Now, the ketone is a more electrophilic carbonyl carbon than the ester. Go back and redraw the resonance forms of an ester. Recall that this oxygen has lone pairs that are in conjugation with the carbonyl carbon. Draw those resonance forms if you don't see them. I'll push the arrows here, but I'm not going to draw it. You draw it as an exercise. All right, so that's a little bit about the scope and limitation of the Grignard reagent. It's very, very useful. But there's some more things we need to recognize about it. And that has to do with limitations. it has some pretty severe limitations. Remember, this is phenyl Grignard. We have a metal carbon bond, and although Grignards are not as basic as lithium reagents, they're still very, very strongly basic. pKa's around 35, so anything that's acidic, any acidic functional group will first simply protonate the Grignard, because moving a proton is an easy reaction. Remember, the hydrogen atom, that's the lightest nucleus we need to deal with. And so anything that has an acidic hydrogen, like alcohols, like thiols, like amino groups, or even carboxylic acids, of course, will only give up their proton and they will protonate the Grignard reagent long before, in a much faster rate than it can react by getting these two heavy species together. The other thing is, obviously the Grignard reagent reacts with lots of functional groups. So you have to avoid reactive functional groups. We don't want to react with the functional group. So then anything that it reacts with, you can't have another aldehyde, ketone, ester, amide, or any of those carboxylic acid derivatives that will react with carbonyl or Grignard reagents.